Hello students, I am Dr. Sanjay Ponia. In last lecture of computer arithmetic, in computer architecture, we discuss about the representation of number systems, and then we discuss the representation of binary number systems. After completing the binary number system, we discuss the basic rules of arithmetic operations, that is plus, minus, and in the last lecture, we discuss about the addition and subtraction rules. In this lecture, we will discuss about the representation of binary numbers and different operations. Those are performed on binary numbers, and we will try to understand the overflow also. Overflow is the main concept in addition as well as in subtraction or in computer arithmetic. So we should try to understand overflow very clearly. So let's start from the arithmetic operations of addition and subtraction. First, we will try to understand that how many different numbers we can represent by different bits. As we discussed earlier also, that if I have a number where the bit of that number is 1, means we have a 1 bit number. In that case, we can store either 0 or 1, means we can store any of one value from 0 or 1, and total possible combinations in case of n bit is 2 raised to the power n. 2 raised to the power n. From this, we can find out that how many different numbers we can make by using different bits. As this is for 1 bit, if I am taking the example of 2 bits, then in that case, this will be 2 raised to the power 2, value of n is 2 over here, so 2 raised to the power 2 is 4. So we can make 4 combinations, and we know it that these are 0, 0, 0, 1, 1, 0, and 1, 1. So these are the 4 different possibilities when we have 2 bits to store the number. In the same way, when we have a 3-bit number, then we can store 2 raised to the power 3, that is equals to 8. Means we can store a number that have 8 different values. So always we consider that it starts from 0. So if there are 8 values and we are starting from 0, then this is from 0 to 7. 8 numbers are from 0 to 7. As we are taking an example of 4-bit number, we are taking the example of a 4-bit number to understand the concept of arithmetic operation as well as overflow, then first we should try to understand different possible combinations or the different possible representation of a number. So if I have a 4-bit number, this is 0, 1, 2, 3. So this is a 4-bit number. I told you that this bit, this is MSB. MSB. So this bit is used to represent that a number is positive or negative. So this sign represents the 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 value that is positive or negative. So this tells that the value of this number can be positive or negative. We discussed this also when we studied sign magnitude form. Sign magnitude form where first bit, that is MSB, most significant bit, is used to represent the sign of the number, and rest of the bits are used to represent the magnitude of the number. So if I have a 4-bit number, then first bit MSB is reserved for the sign of the number. Then how many numbers I can store in this? This is 2 raised to the power n, that is 2 raised to the power 3. So I can store only 8 numbers over here. That is, you can see from here, when I am dividing this, let me clear it. Okay, I divided this circle in 2 parts for your easiness. In one part, we are going to represent the positive numbers. In another part, we are going to represent the negative numbers. As I told you that first bit is used for the sign. So this first bit, you can see in all these numbers, first bit is 0, 0, 0, means all the numbers contains first bit 0. And when we are saying that it is a negative number, means first bit of that number is going to represent a negative number. So this one represents a negative number. So in the right hand side, first bit, that is MSB, most significant bit, represents the value of the number, that the value is positive or negative. As when we are leaving this sign bit, then in that case this is 0, 0, 0, means the magnitude of this is 0, 0, 0, and when this is a binary number, then binary equivalent of this in decimal is 0. So when I have to represent a 0 number, a 0 decimal in binary, then I can represent in 0, 0, 0. And when this is a positive number, then I have to put a 0 before this. So this is 0, 0, 0. This is 0, 0, 1, means this is the representation of plus 1. This is 0, 1, 0, means presentation of plus 2. This is 0, 1, 1, that is plus 3. This is 100, that is plus 4. This is 101, that is 5 plus 5. This is 110, that is plus 6. And this is 111, that is equals to plus 7. Now by using these three digits, we can represent only 8 numbers, that is 2 raised to the power 3. We discuss about it, and those are going to start from 0 to 7. So this was about the positive side. Now in the negative side, I told you that when I have to write a number in 2's complement, suppose I have to write minus 5, then what we have to do? First, we have to write down the binary equivalent of plus 5, and that is equals to 101, and as this is a positive number, so a 0 will be over here. So the binary equivalent of plus 1 plus 5 is 0101, and we have to find out the 2's complement to find the negative number. As I told you, the direct method to find the 2's complement, that we have to start from right to left. Write first one as it is. Write first one as it is, and after that flip the 1 into 0 and 0 into 1. So instead of 0, now it is 1. Instead of 1, it is 0. And instead of 0, instead of this 0, this is 1. So from here also you can see that this is, it tells that this is a negative number. And this is the representation of minus 5. You can confirm this from here that this is 011 and this is also 011. So this is the representation of minus 5. In the same way, suppose we have to find out the representation of all the numbers from 1 to 7, then we will find the direct 2's complement of this number. This is plus 1 and this will be minus 1. So 2's complement of this will be, first we will write this number as it is, then we will change all these three bits from 0 to 1. So this is the 2's complement, that is negative representation of plus 1. Same, when we have to take the 2's complement of 2, then this first bit is 0, so we will write as it is. First one we get over here, so first one we have to write as it is, so we write the first one also, and after that we have to change the numbers. So we change these two numbers, that is 0 0 to 1 1. So this is the binary equivalent of minus 2. In the same way, you can check that the binary equivalent, that is representation of 3 in minus 3, means in negation, or in 2's complement, is we have to start from here. We have to write first one as it is. So we write first one as it is, and after that we change the digits from 0 to 1 and 1 to 0. And same this you can find for plus 7 and minus 7. Plus 7, this first bit is 1, so we will write first bit as it is, and after that all the values of all bits are going to change from 1 to 0 and 0 to 1. But as we discuss that the range of a number in 2's complement form is 2 raised to the power n minus 1 into 2 raised to the power n minus 1, and this is minus 1. This is the range of a number in 2 raised to the power n. So when we have to find out in the range of a digit where numbers are 3, where the bits of a number are 3, so this is 2 raised to the power, okay, total digits are 4, total digits are 4, so 2 raised to the power 4 minus 1, that is 2 raised to the power 3. And 2 raised to the power 3 means this is minus 2, this is plus, this is 2 and this is plus. So 2 raised to the power 3, 2, this is minus 2 raised to the power 3, to 2 raised to the power 4 minus 1, that is 3 and minus 1. So this is 2 raised to the power 3 is minus 8, and 2 raised to the power 3 is 8 minus 1, that is, this is minus 8 to 7, minus 8 to 7. So you can see from here that in positive side this is plus 7, whereas in negative side this is minus 8. So, and second thing that we discuss that in 2's complement the representation of a 0 is only 1. The representation of plus 0 and minus 0 is only 1. So this is the reason that in negative side it is going from minus 1 to 8, minus 1 to 8. When we have a 5-bit number, then the values will be from minus 16 to 15, as we saw in 4-bit that the values are from minus 8 to 7. I think representation of numbers using different bits will be clear to you now, because we have discussed all these things earlier also. So now this was about the representation. Now we will try to find out the different arithmetic applications. So first we will see for addition, that what happens when we have to add two numbers. First, we are keeping the constraint of 3 bits to understand the things easily. So this is, we have to add plus 3 to plus 2. So we have to start from we have to start from here. So this is 0 0 0. So we have to count 3 in positive direction. So this is 1, this is 2, and this is 3. So this is plus 3. Now again we have to add 2 in this. So this is 1 and this is 2. So the value is 5. You can see from here. If we are performing in this, if we are performing this in decimal number also, then you can see that when I add 3 with 2, then it is 5. And representation of 3 is, representation of plus 3 is 0 0 1 1, and representation of plus 2 is 0 0 1 0. And when we have to add these two numbers, that is plus 3 and plus 2, then this is 1 plus 0 is 1, 1 plus 1 is 0 with a carry 1. So this is here will be a carry. So 1 plus 0 plus 0 will be 1, and 0 plus 0 is 0. So we can see that we get a positive number. We get a positive number where the value of this is 101. So you can see from here that the value is 101. The value of 3 is 011. The value of 3 is 011, as I tell you here. And the value of 2 is 0010. You can see from here. So when we have to find out the addition of two positive numbers, then in that case we can add the numbers in such a way that start from 0, and access total numbers, access total steps, those we have to add. So we have to add 3 over here. So access 3 steps from here. So this is first step, this is second step, this is third step. Means now we get the first number. Now again we have to add two numbers in this. So again we have to move in positive direction because the numbers are positive and we are adding. So two more position we have to go ahead from here. So this is one position and this is second position. So the sum is plus 5. So I think when we have to add two positive numbers, then there will be no problem in adding the numbers. I think it will be not very clear to you. There should be no doubt at all about it. Now, about the subtraction of two numbers. In subtraction, as I told you, that first we have to, okay, let's try to understand it in another way, that we have to add 3 with minus 5. If we will try to see from here, to see from this expression, then this is 3 minus 5. But as I told you earlier, that each and every operation is going to perform as an addition. inside computer. So there is no negation, or negation cannot be performed directly. We have to take 2's complement and have to add that in the other number. So this is 3 plus minus 5, means in that case when we have 3 plus 2, in that case we were going 3 steps ahead in the positive direction. This is 1, this is 2, this is 3, and we are adding positive 2. So 2 more steps we have to go in the same direction. We discussed this in the last slide over here. So when we have to perform this, then in that case, when we have to add the things, then we have to move in the right direction, means in the positive direction. And as I told you, when we have to perform a negation or with a negative number, we have to add a negative number, then we have to go in the reverse direction. So this is also the addition of 2 numbers, but one number is positive and one another number is negative. So we have to approach 3 in positive. So this is 0, this is 1, this is 2, and this is 3. Now as we have to add, but we have to add minus 5 instead of 5. So we will add 5 more steps, that is 1 step, 2 step, 3 step, 4 steps, and 5 steps. So this is minus 2. You can see also from here that if I have to write plus 3, then plus 3 will be equals to this, that is 0, 0, 1, 1 to minus 5. So the value of 5 is value of plus 5 is equals to 0, 1, 0, 1. And when I have to write minus 5, then in that case we have to take the 2's complement of plus 5 and start from right to left. See the first one. First one is on the first bit, so write as it is, and after that replace the digit with 0 to 1 and 1 to 0. So instead of 0, now it is 1. Instead of 1, it is 0, and instead of 0, now it is 1. So we have to add this in 3. So this was plus 3. Now we have to add minus 5, and minus 5 is equals to, this is the representation of minus 5, that is 1, 0, 1, 1, 1, 0, 1, 1, and by adding these two numbers we are getting 1 plus 1 is 0 with a carry 1, and 1 plus 1 plus 1 is 1 with a carry 1. Now 1, this 1 plus 0 plus 0 is 1, and again 0 plus 1 is 1. From here we can see that this is a negative number, this is a negative number, and if this is a negative number, means it is the 2's complement of the number whatever we have. So we have to take the 2's complement of this number to find the value. So we know that this is the 2's complement of 0, 1, 0. That is 2. So this is the 2's complement of 2, and because of this minus, we are writing minus 2. So when we have to add a negative number in positive number, then we have to find out the 2's complement of a number, and after that we have to add the number. So in case of addition also, in case of minus also, we have to perform plus operations by taking 2's complement, that is negation of that number. Now we will see what is overflow and how it happens. Overflow is the condition where the result is more than the bits I can store. For an example, as I know that in 2 bits number, in 2 bits number, I can store 000 to 111, and this is equivalent to 000 is equivalent to 0, and 111 is equivalent to 3. So I can store 0 to 3. But if I get the result of addition of two numbers, for an example, when I am adding 2 and 2, then I am getting 4. But we cannot store a 4 in 2 bits number. So this is called the overflow. Means when the result is more than the value that we can store, that's the overflow. From here, we will try to understand that when we are adding a number, that how we are getting a minus after adding two positive numbers. See, the binary equivalent of 3 is, the binary equivalent of plus 3 is this 0 represent that this is a positive number, and 0 and 1 and 1. So this is the representation of plus 3. When we have to write plus 6, means this represents a positive number, and 6 means this is 4 plus 2. This is the representation of 0. When we have to add these two numbers, then this is 1 plus 0 is 1. 1 plus 1 is 0 with a carry 1. And this is 1 plus 1 is again 0 with a carry 1. And 1 plus 0 is 1. So from here we can see that this is a negative number. After getting the sum of two positive numbers, we are getting a negative number. When we have this negative number, so we will try to find that which number is equivalent to this. So first we have to convert this negative number into the 2's complement form. So when I am going to write the 2's complement form of this, so this is 1, and this is also 1, and this is also 1, and this is 0. This is 0. So means this is equivalent to 7. but as it was 1 means it represents that the number is negative means it represents -7. From here also you can see that we are getting 1001, 1001, and this is equivalent to -7. And in simple way, as I told you that when we have to add two positive numbers, then we have to follow the graph in right hand side means we have to the same numbers on the right hand side means when I have to add 3 with plus 6 means both the numbers means we have to add in positive direction. So from here we have to go 3 point ahead. So this is 1, this is 2, and this is 3. Now again I have to add, and we have to add a positive number. So we have to go in the same side, and the number is 6. So we will go 6 steps ahead. So this is 1, 2, 3, 4, 5, and 6. From here you can also see that we reach to -7 instead of 9. Instead of 9. Because we can't say a number more than +7. More than +7 in this. So when a number is more than +7, for an example, if a number is 8, then there will be a overflow. So this is the case of overflow in addition. Now we will try to understand the underflow also. The underflow in case of negative numbers. In case of negative numbers. Means in case of overflow, in case of overflow, the values reach from positive to negative, and in underflow, values reach from negative to positive. So this is the case you can see from here. From the positive direction, we are reaching from positive to negative over here. So this is the overflow. And in next, as we are approaching from, we are approaching from this -2 plus, then this is a underflow. This is a underflow. -2 plus. Sorry, instead of overflow, it should be underflow. It should be underflow. Let me tell you this also. When we have to add -3 with -6, so we know that the operation only addition is going to perform. So we will write the equivalent of -3. So to write the equivalent of -3, as I told you, first we will write the equivalent of +3, and +3 is equals to 0, 0, and 1 and 1. as this is a positive number, so first bit represents the number, and when we have to find out the minus 3, then in that case we have to start from right to left. We have to start from right to left, and when first one, then write the first one as it is, and after that flip the values, that is 1 to 0 and 0 to 1. So this is the binary equivalent of minus 3. Same, we have to find out the binary equivalent of minus 6. So plus 6 is going to represent by, this is 1 1 0, and as this is a positive number, so sign bit is also 0. When we have to find minus 6, then we have to write 2's complement of this, and 2's complement of this is first bit is 0, so write it at it is, this bit is 1, so write first one as it is, and after that change 0 into 1 and 1 into 0. So instead of this one, it will be 0, and instead of this 0, it will be 1. So this is the representation of minus 6. This is the representation of minus 3. Now we have to add minus 3 and minus 6. So minus 3 is 1 1 0 1, and minus 6 is 1 0 1 0. This is 1 0 1 0, and after adding these two numbers we get 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 0 with a carry 1, with a carry 1. So here is a carry, but the sign bit is 0. It says that the number is positive, as sign bit contains a 0, so it says that a number is positive, and when the number is positive, then rest of the bits of this number shows the magnitude of the number, and this is 111 equivalent to 7, as 0 is over here, so this is plus 7. It should be minus 3 plus minus 6 plus minus 6, so it should be minus 9, but we cannot store a value more than minus 8 in this case. So this is the reason this is called overflow, underflow. And as I told you, another method also we will try to find out by that. When we have to approach minus 3, then we have to go 3 steps in negative numbers. So this is 1 step, 2 step, and 3 step. After that, this is also a negative number. This is also a negative number, keep in the mind. So we also have to go in same direction 6 steps ahead. So this is 1, 2, 3, 4, 5, and 6. Now it's changing from negative to positive. This is a underflow. So I hope now underflow and overflow will be clear to you. There will be no confusion. Now we will try to understand that how we can check by the circuit diagram that there is a overflow or underflow. We studied this for 4 bits only to understand the things easily. Now suppose I have a n bit number, then we will discuss for n bit number that how we can find out that there is a overflow or underflow. Suppose we have n bit number and after addition we get n plus 1 bit. Suppose I have 3 bit number and after adding any of the numbers I get 4 bits. Then as the number can store only 3 bits, then where will be that 4? For an example, after addition I am getting this 4 bit number instead of any 3 bit number. Then where will this bit go? This is the problem. So this is stored in a flag. This is called carry flag. Carry flag tells us that there is a overflow or not. When there is an extra bit after addition, then we can say that there is overflow by seeing the value in the carry flag. But it's not in the case always. You can see from here that overflow is when we have two positive numbers. It is when we have two negative numbers. When we have to add two negative numbers, there is the underflow. When we have to add two positive numbers, then there is the overflow. And when one number is positive, one is negative, then there is no problem. One, so this is the thing that we have to consider about the number systems, that numbers are positive, negative, or whatever. So this n plus 1th bit, this is n plus 1 bit going to store in carry flag. For an example, from here you can see that we have 3 bit number, and after adding these two numbers we are getting this as 1 and 1 is 0, a carry over here. This is 1 and 0 and 1 is 0 with a carry 1, and 1 and 1 and 1 is 1 with a carry 1. So 1 plus 1 is 2, 2 plus 1 is 3, and 3 is equivalent to 1, 1. So we get one extra bit. This bit is going to store in carry flag. Now we will try to understand that how we can find that there is a overflow or not in case of n bit number. Suppose we have two n bit number. One is a, this is a n bit number. Second b, this is also a n bit number. We know that MSB in all the numbers, MSB in all the numbers shows that the number is positive or negative. Positive or negative. So this is the most significant bit. So here can be two cases 0, 0 and 1, 1. As I saw you in the last that the numbers can be -5 plus -8 means both the numbers are positive or both the numbers are negative. So we will see these two cases, that is when both the numbers are negative and when both the numbers are positive. This is a carry in from the last position. This is a carry in from the last position. This is carry out. This is carry out that will be considered for the carry flag. So we will understand these two examples separately. First, we will see for the positive numbers. When we have two numbers A and B, as I told you just now, and these two numbers are positive, means MSB of these two numbers is 0. Means MSB of these two numbers are 0. This is the MSB of first number. This is the MSB of second number. And when we are adding these two numbers, and we are also getting a 1 from last bit, means the C in is equals to 1. C in is equals to 1. And after summation, in the result, values change from 0 to 1 and there is no carry out. Then in that case, this is the condition of overflow. This is the condition of overflow. Suppose we have a 4-bit number, then you can see this by applying when I have to add 0, 1, 0, 1 with a number 0, 1 and this is 0, 1, 1, 0. When we will add these two numbers, as these two numbers are positive, so 1 and 0 is 0, 0 and 1 is 1, and this is 1 and 1 is 0, means we are getting carry from the last bit, means this is C in. And after adding these numbers, I am getting 1. Means now the result is changed from 0 to 1. And the C in, carry in is also 1. I am not getting C out anything. Means this is 0. Here is no carry. So in that case, this is the case of overflow. Same when we have two negative numbers. This is first number A, this is second number B. As these two numbers are negative, it means in MSB there will be 1 in both the numbers. So A n minus 1 and B n minus 1 both are 1. And there will be no carry from the last digit. And after the result, this 1 changes to 0 as well as we get a carry. We get a carry. In that case also, there is the overflow. Let me tell you this also by an example. Suppose the number is minus, suppose the number is minus 6. This is the representation of minus 6, and we have to add a number that is minus 5 in this. So representation of minus 5 is 1011 in 2's complement. When we have to add these two numbers, then this is 0 plus 1 is 1, 1 plus 1 is 0 with a carry 1, and 1 plus 0 plus 0 is equals to 1. So there is no carry from the last digit. So C in is equals to 0. And when we are adding these two, so 1 plus 1 is 0, and we are getting a carry 1. So we are getting a carry 1. So this condition fulfills, it means we have the number where there is a overflow in adding these two negative numbers. We can find out that in our circuit there is a overflow or not by checking C in and C out. C in and C out means either we are getting a carry in or we are getting a carry out. From here, you can see that C in is 0. In negative numbers, C in is 0 and C out is 1. In the last case, in positive numbers, you can see that when these two are positive numbers and C in 1 and C out is 0. In these two cases, there is an overflow. So we can use a XOR gate to perform this. So this says when we have two inputs X and Y, we studied this. This is our result. So it is represented by R is equals to X y bar plus X bar Y. So this is the equation for XOR gate. So when any one of these is either we will get a value from here or a value from here. If any one of these two is 1, it means there is a overflow. Means either this is means carry in is 0 or carry out is 1 if I am taking in reverse direction, or if x is 1 if carry in 1 and carry out is 0 in first case, then this is a overflow. In second case, as carry in is 0 and carry over is 1. Carry over is 1, and this is also 1. You can see from here that in first case, C in 1, C out 0. In second case, C in 0 and C out 1. So we can use XOR gate to find that there is a overflow or not. When any of these two are different, it means there is an overflow. And when these two are same, in that case, there is a not overflow. It means by using the XOR gate between C in and C out, we can find out that there is a overflow or not. So let me summarize what we discussed today. In today's class, we discuss about the addition, subtraction, representation of positive numbers, representation of negative numbers in a circle, then addition operation as well as subtraction operation. Then we see the overflow in addition, underflow in subtraction. Then we discuss about the carry flag, that when the carry flag is 1 and how we will came to know that there is a carry or not from the numbers. Then we discuss that how we can find out that a number is overflow or underflow and how we can find this by using the XOR gate. So this is the complete discussion and summary of today's lecture. In next lecture, we will discuss about computer architecture for multiplication or addition, or maybe we will see some examples or advanced concept about the computer arithmetic, that is addition.